Yesterday, we went through electron configuration, and we started out with hydrogen. If you were gone yesterday, this is going to be really tough for you to kind of understand, and I'm going to move on because the video is on. The video is on Google Classroom. It's about 18 minutes of discussion. Okay, and if you want to catch up, you can always go there. Write down some questions in your notes, come in and ask. But we're not going to go backwards and wait. We're going to just review a little bit and we're going to go forward. So hydrogen has that one electron there. We started out with that and we said it's in the first energy level. Sometimes you'll refer to it as a shell. So some places say shell, some say energy levels. But it's at first level and it's 1s1. Okay, so the 1 represents the level, the S represents the subshell, and the 1 just keeps track of how many is in that sublevel. Make sense? The S's can have 2 in it, the P's can have 6, the D's can have 10, and the F's can have 14. So, and if you count across the rows on the periodic table in those blocks, you know where you're at. So if you remember, this is our map. This is S's, this is D's, there's 10 of them, these are P's, you count across, there's 6, and these are F's, there's 14. So you know where you're at if you're following along with the periodic table. So then we also did nitrogen, and nitrogen had 7. And so we knew that 2 was in the first level, and we knew that 5 was in the second level, but they were different sub-levels. Okay? 2 of them were in the S, because the S's always come first. In every level, S's are filled first. Every level. We get to the third level, they're filled first. We go to the fourth level, they're filled first. Then it becomes P, and then D, and so on. So then, as you count across, your lithium, beryllium, and now you're over into P's. Boron, carbon, nitrogen. There's 3 of them. So then you would say 2P3. Any questions you have on that up to this point in time? That makes sense? Questions you guys have that I can answer or help you out with. Okay, we haven't got to the D's. We won't get to the D until element 21. Because this is the D's. Okay? So we don't get to a D until we're in element 21 and in this middle section. Okay? So we're going to get to the D's here today. So then we didn't we do a P? Right? Okay, phosphorus. Now phosphorus is right under nitrogen. And so we did phosphorus, we said it was 1s2, 2s2, 2p6. So that would be like this. Okay? And then, within that next level, we've got to have 15, so we've got to have 5 more. So there's the S's. They're paired up. And so it would look just like nitrogen, but 1 level out. So then we'd go 3s2, 3p3. Any questions with that? So we go S, SP, S, and S and P, right? Now the thought is that the next electrons that you would have to fill after the 3p would be the 3d, right? If that pattern continues, you go S, SP, SPD, and then SPDF, and then so on and so forth. But what happens is we have an electron has its choice. So the next one we're going to do is we're going to do potassium. Okay? So we're going to do K. We're going to do element 19. Now right away when you look at it based upon what I told you, what should be the last thing you write down for the S? And you're thinking, wait a second, shouldn't it be D? You say, well, it should be the 3Ds because if we keep on going and fill the sub-levels up within the levels, then the next one should be the D, and you're saying it's an S. Because we said all these end in the same sub-level, S. So how can that be? How can that be an S when it should be, along with the pattern, it should be a D? And so this is what happens. The electron has its choice. It can go to the 4s or the 3d. Okay, as you're going along, in that progression, again, it has 1s, 2s, 2p, 3s, p, d, and then 4s, p, d, and f. So the electron has its choice between this one and the 3d. Which one will it choose? It will choose to be in the 4s. And why? Because the 4s combination is less energy than a 3d combination. Remember, the d is a really complex orbital. So the s will choose a orbital that is the lowest energy. It always chooses the lowest energy. Okay? So, but if you're using your periodic table, you know what comes next. That's the nice thing with the periodic table. Because when you do a configuration, we're going to do it here in a second, and you get the argon, and then you come over and you got to get the potassium, we know that this is the S sublevel and it has to be filled. So that's what we're going to do right now. We're going to go ahead and take. This is what happens. It gets the S's and P's. Then what happens, it will come out here and fill an S out here before. These are D's. There's 5 more D orbitals in here in that third level that can be filled. But they're going to choose to fill the 4S instead of the 3D. Okay? So, what I like to do is I like just to use the periodic table as my guide and my map. And if I can use that as the map and go along, then that's what I will. That's what I'll do. Okay. I'm not very good about that. So I want to get right here, right? Is that potassium? I want to get there, potassium. So, now, the nice thing about this, you're not going to have to do the longhand version all the time. It gets laborious, it gets tiresome, I don't like doing it. I would much rather, like on a map, sometimes if you have directions to get from here to Council Bluffs, Iowa. Someplace in Council Bluffs, Iowa. Okay? So, it's like I know how to get between here and Lincoln. I don't need a map to tell me how to get to Lincoln. And I know how to get to Lincoln to Omaha, so I don't need a map to tell me to get. I need to know a map that maybe gets me from Omaha to Council Bluffs somewhere. Does that make sense? So, on this, we're not going to have you start out at the same point every time. And I'm going to give you a shorthand here in a second. And we're going to base it upon the ones we've already done, so you can actually see how it works. Okay, so let's do potassium, the longhand version. So, we're just going to use the map. We're not going to use that little circle. So, 1s2, where am I at on the map? Helium. Does everybody see where I'm at? Helium. So, if you don't have your periodic table, have it out. If you want to look up there, that's fine. You'll always need your periodic table to do these, so you can either look up there, follow along, or have your own periodic table out. So right now we're at helium. Okay? Next thing, 2s2, where am I at? Beryllium, I'm right here. See, I'm going in order. So now I got to go through all of these right here. So, I'm going to go and count through those. How many are there? 6. And so, what level that has 6 electrons in it? It would be what? The 2, P, 6. Where am I at?
We're now at neon.
Neon. Okay, what comes next? I'm over here, right? Third third period. That is what? Free what? S. Every level fills with S's. So if I know I'm in the S's over here anyway, on the left side. So that's 3s2. I'm right here. Now I'm going to go through this section. These are the what? P's again, right? And there's 6 of them. So I go 3p, 6, I'm at argon. Okay, I got 1 left. If I count up, I got 2, 4, 10, 18. I've got my 19th electron. It's over here. So these are the what? S's. What level are S's? 4. Okay, now I'm going to tell you a little trick that if you count down the periods, they tell you what the S's and P's are. So every time when you count down your periods, period 1, period 2, period 3, period 4, that tells you your S level and your P level that those sublevels are in. So that'd be 4S1. Make sense? Now, the problem is when we do one that's a D. And we get our first D. So let's do this before we get to the D's. Let me show you what's called an abbreviated way in which to do a configuration. So you guys already have some of these already done. Okay? So let's look at nitrogen. Okay, so you can look at nitrogen. You don't have to write this out. You can just observe nitrogen was 1s2, 2s2, 2p3. Right? Now, an abbreviated version, what it does is it starts from the noble gas that's in the row above the element you're doing a configuration for. So what's the noble gas above nitrogen's nitrogen row? So which noble gas preceded the element nitrogen? Helium. So, and it doesn't make a lot of sense on these easy ones, but it's good to show you. So what I'm going to do is I'm going to put helium, put it in brackets, I'm going to start from helium. So what comes after helium? Right, will be the second row, or second level. So I'm going to put 2s, 2, 2p3. So what I'm doing is I'm saying, okay, I know the configuration through helium, and so I'm going to do that configuration. Okay? So let's do phosphorus. You guys had phosphorus. And phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. So on this one, I'm going to do the same thing. I'm going to look at the noble gas directly above that preceded the row that's phosphorus in. So what element's that? So I'm going to put neon in brackets. I'm going to start from neon. So then if I start from now, when you do the abbreviated version, S is always listed first. So then I count down and I look, phosphorus in the third period. So I'm going to put what? 3 S2, 3p3. See how much easier it is? I don't have to list out all of these elements preceding phosphorus. And the reason we do abbreviated version is because in the future, we only are concerned with the outer electrons. And these are the outer electrons. So phosphorus and nitrogen, how many electrons do they have in their outer level? 5. And I guess you could probably tell me how many arsenic has in its outer level.
6.
Is arsenic below phosphorus?
Oh, that's 5.
5. Everything down that row will have this configuration, okay, to where they'll have 5 in the outer level. Make sense? So now let's look at the one we just did. Okay? Look at the one we just did here. Look how much we had to go. So let's do, this is potassium. So let's do potassium. So potassium, what's the noble gas in the row preceding it? So look how easy this is going to be, guys. I'm going to put argon, And then you're going to count down the row. And you're going to count down 4. So you're going to put 4 S. Look how easy that is. Instead of writing all these out, you now know a lot of configurations. You know how, for most of you, you'll know how you got to that point of this 4s1. So now you're saying argon is where I'm starting, and then I'm going to say 4s1. Does that make sense? Okay, questions you guys have? I know I'm going through it pretty quick, but I want to have you guys time to ask some questions as you go through it on your own. Because that's where you really learn, is doing it on your own. Okay? Now, we're going to do 2. All right? And these 2, I want to see if you can do the long hand. Okay? And what I'm going to have you do is vanadium. And vanadium's element 24. Is it 23? Yeah. 23. So then what I want you to do is I want you to go ahead and start with hydrogen. Use your periodic table to know where you're at. And then I want to see if you can come up with the answer for vanadium. Okay? And I haven't showed you how to do the D's yet, but I want to see if you can figure that out, and then we'll go through it and see how close you were. You guys know the different blocks? You know what's getting filled. As we get, it's kind of like our map. Remember, our map, again, is here. And I'm just going to go through the map, and you guys will be able to tell me where I'm at different portions of the map. And if you're not sure what to do, then this is your map to get to your location. Alright? And there's 1, 2, 3, right? So this is what I want to get. So I go 1s2. I'm at helium. 2s2. Right there. See, I'm in the S's. Second period. The period represents the S's and P's. Then I'm here. Okay? 2p6. Now 3s2. I'm here. Third row, third period. 3p6. I'm right there. So 1s2, 2s2, 2p6, 3s2, 3p6. Now I'm over here and I got to fill these 2. These are S's. 4s2. Now I'm here. These are the what? The D's. There's 10 of them across. Okay? There's 10. So I need to get here where the X is. So that's the D's. But what level of D's? 3. Okay? The 3 D's. Because the D's haven't been filled yet. We go S, 2S, 2P, then 3S, then 3P, then 4S. Kind of see that pattern there? 1S, 2S, 2P, 3S, 3P, 4S. So what comes next in that pattern? 3D. So that would be 3D3. Makes sense. Last one. Would like you. Oh, let's do the noble gas configuration for this. So this one is definitely this is one you want to do a noble gas configuration for. So what's the noble gas above vanadium? So argon. Then 4s2. 3D3. We're done. Some questions? Okay, but you got the D's are what students mess up on. So on the test, what they'll do is they'll not know where the D's are at and what level they come in. Okay, they can get the S's and P's, but then the D's just throw them for a loop. They're just like, man, I don't know where D's come in. They always are one behind or one, I guess, one less level. okay, than the S's that you write down. Yes?
Will you turn off on the test if we put 3D before 4S?
No. Now, this periodic table, if you notice on there, they give you some shorthand configurations already. If you haven't noticed that, they show you some. You guys see that? So look at vanadium and look at the shorthand they give us down above the word vanadium. 4s2, 3d, 3, right? Now some of these are exceptions to the rule. They have what naturally occurs and then what possibly occurs. You can't use this on the test though, because it kind of gives away the answer.
Will you give us like a different one without?
I'll give you a different one. There'll just be a periodic table with the symbols and the numbers on there. So, okay? And you can't always go by this because they have some what they call exceptions to the rules that we're going through. All right, so the last one. Don't look at that ever until you're done. Okay? And then you can check it. So the last one I'm having you do is, to see if you can do it, is strontium. SR. Element 38. Do the longhand version. Now, in the future, you guys will get your choice if you want to do longhand or abbreviated. 9 people out of 10 will always do abbreviated. But we will have some that will I can't do abbreviated. I don't know where it comes in. I'm not comfortable about using it. And I'll grade those, but they're not fun to grade because when you get down to 57 electrons that you got to show where they're from hydrogen all the way, it's just like, oh, it's not. So do strontium, and let's see if you get the answer. Do not look at the answer that's on the sheet. If you want to keep away from that, just use your back side. Okay? And then you can just use the back side of that periodic table to kind of help you out. Okay, so 1s2, 2s2, so I'm at argon, then I'm at 4s2, I'm at calcium. I did not do the D because a 4s is less energy than a D. Now I'm in the Ds. I have students, a lot of students will write 4D because they think it should go in order, 1s, 2s, 3s, 4s. But if I write a 4D, what happened to the 3Ds? We didn't even fill them. You got to fill the 3Ds because they're lower energy. This makes sense. They're lower energy than a 4. So you go 3D, 10. Now you're in what level? Or what sub-level? The P's, right? You're at gallium. You got to go gallium to krypton. So what level are those? 4. So 4p6. I'm at krypton. I got to go one more, right? Mm-hmm. Or 2 more? 2 more. Yeah. 2 more. So now I'm at the S's. I've already got the 4's filled, and that's also the 5th period, 5th row down. So I'm going to go 5S, what? 2. So then you go abbreviated. What is that? So then you go the noble gas above there, which is what? Krypton? So you go KR, 5S2. You're done. You're done. You don't have to show all of this in the future. You don't have to show all of that. Because what's all of that? Where are you at when you're here, 4p6? Krypton. You're krypton. And we're only worried about the outer electrons in the future.
So can we do shorthand on this worksheet too?
So I'm making you at least do 4 longhand for the first 4, and then 5, 6, and 7, you don't even have to do the longhand. You can do abbreviated. But I need you to do 1, 2, 3, and 4. Okay? So I'll come around if you guys have questions on that.